Hi guys, I just wanted to take a quick look at a problem from the practice test that we all had trouble with, and give you a chance to practice it a little bit more and earn some points back, actually. So let's look at this. Sorry, I'm in a car, so if it sounds like I'm in a hole, I kind of am. But real quick, let's take a look. So here we got a piecewise function that you've seen, and we want to find some stuff out about it here. So here we go. Remember, for each of these, always start with the definition. Now, find the average rate of change. So before you even look at what the numbers are and what's going on, write down what the average rate of change is. That is average rate of change. It's the slope. And then go ahead and get into specifics. Well, what are B and A? It's f of 4 minus f of negative 3 all over 4 minus negative 3. And then we got to ask ourselves, okay, I know that. Now I got to find f of 4. All right. Well, what is f of 4? Well, this is a piecewise. So at x is 4, the function is defined in two different ways. And so f of 4 gets this second piece of the function, this second definition. So f of 4 is... Let's go ahead and just compute that over here. Negative 4 plus 3 times cosine of pi times 4 over 2. All right. Well, this is a 2 pi. Cosine of 2 pi is 1 times 3, which is 3, plus negative 4, which is negative 1. All right. And f of negative 3 is, well, which piece of the function do we get? Negative 3. When x is negative 3, the function is defined here. All right, and so this is the square root of 9 minus negative 3 squared. And that is going to be 0, because it's 9 minus 9, which is 0. All right, so we can now finish this off. We have negative 1 minus 0 all over 4 minus negative 3 is 7. And so this is negative 1/7. Done with that part, moving on. Part B here. Let's write an equation for the line tangent to the graph of f at x equals 3. So we need the derivative, but we need the derivative not just, well, we got to know where we want it. We want it at 3. So we look at the function. So at 3, which is right in this part, it's defined by this function right here, okay, or this definition, negative x plus 3 cosine pi over 2. So let's go ahead and we want to find the derivative with that. So we have, I'm going to write that down so I can go. So we got negative x plus 3 cosine of pi x over 2. That's f of x for this part. Okay, the other part doesn't apply when the x is 3. All right, well, so let's take the derivative. We have negative 1 plus, the derivative of the inside is going to be pi over 2 times the 3 that was already there. 3 pi over 2 times cosine, sine, right? So it's going to be sine, and it's actually going to be negative sine. So let's make that negative, all right? And negative sine of the inside. So we just did the chain rule there, all right? Now let's evaluate it at x equals 3. And so we're going to get negative 1 minus 3 pi over 2 sine of pi over 2 times 3, or 3 pi over 2. Okay, and we can evaluate this. We've got to know our unit circle. So we go back to our unit circle. Where is 3 pi over 2? Well, that is right down here, right? And the sign of that there is negative 1. So we're going to have negative 1 minus 3 pi over 2 times negative 1, which is negative 1 plus 3 pi over 2. Now it's ugly. We can't simplify it. We don't need to simplify it. Just leave it like that. We found f prime, which is our slope. Now we know we need an equation, so we got y minus y1 equals m times x minus x1. So we need an x and a y. So we need to find out what f of 3 is. Again, we're using that piece of the definition. Since we're talking 3 and this is piecewise, 3 falls here. Not using the top, we're using the bottom. Okay, again, we're always asking ourselves, what are we looking for? And then we ask ourselves, how do we get it? So we're looking for 3, so this is -3 plus 3 cosine of, plug in 3 for x, and so that'll be 3 pi over 2. And cosine at 3 pi over 2 is 0, so this is just a -3. All right, so now we've got the point 3, -3. And so we can go over here. We have y minus y1, which is -3, so we plus 3, equals the slope, which is -1 plus 3 pi over 2. Put that in parentheses. If you want to make it one fraction, you could. You don't have to. X minus x1. And what is x1? Well, our x is 3. And there you have it. Okay? Point slope form there. That's the idea. Okay, cruising along. Let's look at the next one here. Now we want to find the average value. Again, we want to go to the definition. The average value is 1 over b minus a of the integral of f of x dx. Notice we're not even thinking about how to do it. We're thinking about what we need to do. There we go. That's what we need to do. Now let's do that. So we have 1 over b minus a. What is b and a? It's 4 minus -3. All of the integral from -3 to 4 of f of x. Keep this real generic. Okay. Now, we need to figure out, well, how do we do that? Well, it's defined differently here. So this graph changes. Okay. So we need to break it up. So we need to take this as 1 over 7, and we need to break it up into 2 parts. We need the integral from -3 to 0, and we're going to need the integral from 0 to 4. All right, and so this is the square root of 9 minus x squared, and this is -x plus 3 cosine of pi x over 2. And don't forget our dx. We need our dx here, dx. Okay, so we got to do those separate. These parentheses are important here. Okay, so you get points for part of this. You get points just for writing that. Okay. Now, this one, we haven't seen this much, okay, in this form. We've seen it, we've done it as a graph. So if you can graph this, this is the graph of a circle. So y equals the square root of 9 minus x squared. We can't solve that with use substitution or anything. We need to know what that graph looks like. And if we square it, this is y squared plus x squared equals 9. If you clean it up, and that is circle centered at 0 with a radius of the square root of 9. The square root of 9 is 3. Okay, and so we have 1, 2, 3, a semicircle there. Okay, and so we need to find the area of that. Okay, so we're being tested here to find out that an integral is area. So this is half of a circle, and so the area is half of pi times 3 squared. So that's 9 halves pi. So that's the area here, 9 halves pi, or 9 pi over 2 if you want. All right, plus the integral here, well, we need to go ahead and find the antiderivative of this. The antiderivative of this, we're going to do this in 2 parts, kind of. Okay, the first part would be -x squared over 2 plus, and this is going to be, maybe I'll write it out part way, 3 times, I'm going to pull that 3 out, the integral of cosine pi x over 2 dx. All right, this is going to be some u substitution. We need to call u pi over 2x. So the derivative of pi over 2x is pi over 2. Wish we had a pi over 2 here. So we're going to have the reciprocal of that, 2 over pi out here. Okay, and the integral of cosine is sine. So it'll be sine pi over 2. Okay. All right. So that's where that comes from. Let you think about that. -x squared over 2. All right. So that's a bit involved. going on there, but we want that evaluated from 0 to 4. And we're actually almost there. So this is 1/7. This is 9 pi over 2 plus, and when you plug in 0 to all of this, you get 0. When you plug in 4, you get 2 pi. The sine of 2 pi is 0, so this whole thing goes away when you plug in 4. And when you plug in 4 here, you get negative 16 over 2, which is negative 8. Okay, and so that gives us 1/7 times 9 pi over 2 minus 8. And you can leave it there. So the last part here, a lot of times this last part is not worth as many points as the previous one. C is usually worth more points. And so let's look at this. Now this is a little different one. We haven't seen this much. You can approach this different ways. Must there be a value of fx that contains an absolute maximum on the closed interval? Okay, well, the key is to show that this is continuous. So we want to show that if this is continuous, then it has to have a maximum. That's the idea. So we need to check it out at the point where they cross, point where they connect. So it's 0. So we need to find f of x coming from both ways. So we need the limit as x goes to 0 from the left of f of x, and that is going to be the limit as x goes to 0 from the left of the square root of 9 minus x squared. Well, that's just plug in 0, and you get the square root of 9, which is 3. Coming from the right side, the limit as we go to 0 from the right side of f of x is the limit as we go to the right side of negative x plus cosine, actually 3 cosine of pi x over 2. Plug in 0 there, and we're going to get 0, negative 0. Plug in 0 here, we get pi over 2. Cosine of pi over 2 is 0. And cosine of 0 is 1 times 3. So this is 3. Okay. So in other words, they're continuous. So f of x is continuous on negative 3 x less than 4. Okay. And so, therefore, it must have a maximum. There's a name for this. You could get away without saying the name, but you could just say it has to have an absolute maximum. That would be fine. The name is the extreme value theorem. I know we haven't talked about that much, but a lot of small little things. But again, if you just said so it has to have a maximum because it's continuous, that would be fine. So f of x, let's say this, since f of x is continuous on negative 3x 4, it has an absolute maximum by the extreme value theorem. Okay, again, if you just said because it's continuous, you'd probably get points there. Okay, extreme theorem. All right, so there's the idea. All right, well, I hope that kind of clears a few things up there. All right, remember, start with your definition and then go look at your function or your graph and work from there. Okay. So now you're going to have a chance to work together on a sample problem like this, and I will replace the grade for this problem with what you do here as a group. No calculators, no notes, just you and your group if you choose to, or by yourself, and we'll replace that. So, all right, great. Well, review, practice, get some good rest on Sunday. We'll see you on Monday. I'm going to have pancakes and breakfast stuff ready at 6:45 if you want to come to class and get all ready for the test and get some food and then take the test. You got to be at the testing room at 7:30 a.m. All right. Thanks a lot, guys. Do well. You're doing great. Proud of you guys. We'll see you soon.